Now we're going to look at writing in rectangular form when we have a domain restriction. Where domain restriction exists is when you have a function that does not allow for certain particular values. So for example, this is a reciprocal function or a rational function, and we know that all functions other than wherever we're dividing by 0 are okay. You're not in math, you're never allowed to divide by 0. So here we have a domain restriction that t cannot equal 0. Because if time equals 0, we're dividing by 0, and that mathematically will not work. Also over here, the square root's not allowed to have negative values. So that means that t plus 1 has got to be greater than or equal to 0. So t plus 1 would have to be greater than, t plus 1 would have to be greater than or equal to 0. And so if you solve this, you can see that we could subtract 1 on both sides and find out that t has got to be greater than or equal to negative 1. So these are our domain restrictions. T cannot equal 0, and t also has to be greater than 1. So let me write it this way. T is going to be greater than negative 1, but yet t cannot equal 0. So you'd have this, and you would have that t cannot equal 0. So you'd write it this way. So if you wanted to, you could put less than 0 and have a union, or say and 0 is less than t, which is less than infinity. You could write it that way, or you could write it as an interval and say negative 1 to 0 and a parenthesis because we're not going to equal 0 from 0 to infinity. This is the way we write an interval notation, and this is set builder. So now let's go through and solve it the same way. Remember how we solve this? We get t by itself. So I'm going to use this equation here, and I'm going to say that x squared is going to equal square root of t plus 1 squared. And the reason I'm squaring both sides, let me change the color, is to get rid of the square root. So x square and square. These go away. So I have x squared equals t plus 1. Finally, I subtract the 1 over, and I find out that t equals x squared minus 1. Now that I know what t is, I plug into the other equation. We'd say that y equals 1 over 2 times, and we said t equals x squared minus 1. Finally, to solve this, I'd simplify by distributing, and so we'd have y equals 1 over 2x squared minus 2 when you distribute. Now, about the domain restrictions, let me show you the picture. What we do is, and I'm going to circle my answer here so we don't get confused, is we're going to plug in these values. So we know that t's got to be greater than negative 1. So the first thing for the restriction is we know that t's got to be greater than negative 1. So I'll put negative 1, and really the value's got to be greater than that. So I'll put x squared over here, greater than or equal to it, rather, minus 1. And so I would just solve this. So I'd add 1 to both sides. And the first thing I discover is that x has got to be greater than or equal to 0. So that's the first restriction. And there's 2 of them, so I'll do this. So there's the first one. Now the second restriction is when t is not allowed to equal 0. So I'm going to put 0 cannot equal x squared minus 1. What I'm doing is I'm plugging it into this equation. And so to solve this, I would add 1 to both sides. And so negative 1 cannot equal x squared. Excuse me. That's adding 1. That's a positive 1. Okay. So how do you get rid of a square? We take a square root. And typically with a square root, you do a plus or minus. And so you would say that x cannot equal plus or minus 1. So positive or negative 1. But this says that x has got to be greater than 0 anyway. So really, this one is obsolete. We don't need the negative 1 because that would be less than 0. So we find out that x squared has got to be greater than or equal to 0, and that x cannot equal 1. And such is the picture. It does not equal 1, and it's greater than 0. And so finally, as we go to write our equations over here, there's one other thing you need to look for. So we could say, over here, I didn't even take the square root, that x here is greater than or equal to 0 when you take the square root of both sides. And you won't need a plus or minus on the 0, which is 0. But as there's one more thing we might notice, when we say that x has got to be greater than 0 and that x cannot equal positive 1, is you might find out that over here, if you were equal to 0, well, no, that would still work. Never mind. I was going to say that would equal 0, but we subtract the 2, so that would still work. So both these answers are valid. X has got to be greater than or equal to 0, and it cannot equal 1. So now I have one for you to try here. I'm going to include this in the answer.